Welcome guys. So we are solving the 39, 40 and 41. So 39 okay. So I think these three problems are simple. So I think I will just catch a picture and write it down the picture so we can solve it. So consider the function is defined by exponential x and divided in from 0 to 10 and divided into some partition and calculate the area. Okay, so we have first a is the right end, right? Because we only take right end sum. So basically I plot larger. Okay, so this is a calculate the right. So this is a. Okay, and b is the left hand sum. The left end. So this is b. Okay, so you know that which following is greatest. You know that b is greatest, right? And the c just take the middle one. So c should be smaller than b. And the e is the integral. Okay, so basically the integral is bounded by the left and the right. So you know that this is larger. And basically this is positive function. So b is our answer. B is our answer. Okay, and 40 of head coin is toss 8 games, or probably more toss will result in the heads. More toss will result in the heads than will result in the tail. Okay. Okay. So 8 times, basically you have 8 results. So this will contain 3 categories. The first one is heads. Number of heads larger than number of tails. Number of heads less than number of tails. The third, number of heads same as number of tails. Okay, and these two should be the same. The probability for these two should be the same because this is symmetric. So all we need to know is, suppose the probability for this is x, then all we need to know is we use 1 minus x and divide by 2. Then we have the answer. So 1 is this. So number of heads equals to number of tails. That means that we have 4 heads, 4 tails. So this is the Bernoulli trial that we take from A choose 2 and take a total is the 8. So we have 8 toss 8 times. So it's A choose 4 divided by 256. So this is so this is 1 minus 70 over 256 and divided by half. So this is 93 divided by 256. So basically you once you find this, you plug it as x, then you can find this. So the answer is E. The answer is E. Okay, and this function has a relative minimum. So basically, let me remind you guys. I already write it many times. So basically, the critical points happen in the partial derivative. I call it f of x, I call it fx, and the partial of y, I call it fy. So basically, this will determine the critical points. Then you can compute a Hessian matrix. So this is fxx, xy, yx, yy. So we have three possibilities. If the f of xx larger than 0 and the determinant h is larger than 0, then this is minimum, a relative minimum. If fxx smaller than 0 and determinant h is larger than 0, this is maximum. And the third is that if determinant h is less than 0, this is saddle point. Okay, so f of x is 3x squared, f of y is 3y. Sorry, I forgot. F of x is y minus 3x squared, f of y is x minus 3y squared. So you solve these two, you get x equal to 3 times 9x squared, 9 to the 4th. So you have x cubed equals 1 over 27. So the critical point is this one. Okay, then we calculate a Hessian matrix. Okay, so let me write again. Hessian matrix is partial derivative with respect to x, and the partial derivative with respect to y. And our point is this one. Wait. Sorry. In important things, I may. So when we solve these two equations, there are two kind of points. One is 0, 0. One is 1/3, 1/3. Because when you plug in these 3 times 9y to a cube, to the fourth power, that you immediately get this one. So you have two kind of possibilities. Okay, so for 0, 0, your h is 0, 1, 1, 0. So this is saddle point because the determinant h is less than 0. When you plug the 1/3, 1/3, you get h equals to minus 2, 1, 1, minus 2. So the first one is negative and the determinant is 3. So this is the relative maximum. So the answer is E. 1/3. So the answer is E. Okay, so we already solved the 39. 39 so is B, and the 40 is E, and the 41 is E. Yeah, so that's the correct answer. So that's it. I hope I see you guys in the next video.